So we've been kind of building up, working our way through that definition of statistics. We've talked about data, how to collect data, how to organize data, and display it with graphs. What we're getting into here in the next section is how to summarize data. So imagine you got a long list of numbers and you need to somehow summarize them. It's a lot different than, like, say, writing a book report. We do have different ways we can go about it. What we're going to focus on today are called measures of central tendency. Sounds like a fancy phrase there. Measure meaning just a number that's measuring something. Central tendency meaning a way to measure the center or middle of a data set. We've talked about one of these already when we did some averaging with our rectangles. It turns out technically there's more than one type of average. When we add everything together and divide by the number of items, there's a fancy name for that. Does anybody happen to know what it is? That's called the mean. So not only can we measure the center of a data set with the mean, like we're accustomed to, but we have a couple of other types of averages we're going to talk about also, like the median and the mode and the mid-range. 4 of them all together. Starting with the mean, I'm going to go into a bit of detail, not because it's so complicated and you've never done it before, but because we have done it before, it's a good chance to get used to some of the symbols that we'll come across. So like we know, the mean is the sum of the values divided by the number of values. In other words, add them all up and then divide by how many. That's what these formulas are trying to indicate. So let's check one of them out over here. We said we're going to sum the values. That's what the sigma and the x here are telling us. So sigma, that's the part that's telling us to sum or add them all up. And what we're adding are the x's. This x here represents all of our data values. So every number in a set, a data set, would fill in for that x. They'd all get added together. And then we said to divide. So that's where the fraction bar here comes in. Divide by the number of values. That's what the n on the bottom stands for. The thing is, when it comes test day, I'll be bringing you a formula sheet. And there'll be things like you see in this box right here on the formula sheet. So if you're able to make use of it, if you can read it and figure out what it's telling you, it can be a big help. Also, as we see more complicated formulas, being able to break them down like this will also be a big help. So something you might notice is this kind of appears to be two versions, two copies of the same thing, right? They both say add up the x's and divide by the n. The n on this side, though, is lowercase. Not only that, the letter, the label on the left of each one is a little bit different. So what we're starting to see here is the different symbols that we use when we're dealing with a sample versus a population. So over on the right, where the n is bigger, that would be representing the number of data values in a population. Capital N for like the overall number. Whereas on the left, the lowercase n, while it still represents the number of data values, this time they would be from a sample. You can see because the formulas are pretty much identical, it doesn't really change what we do. We still add and then divide. It's just the labels, the symbols are different. And that would let everybody know we're dealing with a population if it's capital, or we're dealing with a sample if it's lowercase. Throughout the semester, that will matter to us more and more at different times, so something we want to start getting used to. On the left here, these are both symbols for mean. So different ways we might label a mean, again, based on whether it's from a sample mean would be the one on the left, or a population. Anybody know how you read this X with the bar over it? I mentioned the other day, math folks are not super creative. They call that X bar. On the other side, that's another Greek letter. This one here, it's kind of like a Greek lowercase m. Can you imagine making an M out of that with sort of like a long tail on the left and a little bit of a curl on the right? It's called mu, mu. It's another Greek letter. Well, that's way more detailed than you ever hope to know about the formula for something you already knew how to calculate, right? We don't even really need this formula. We know to add and divide. We are trying to get used to the symbols and the idea of sample versus population. Is there anything in all that mess you'd like to ask about so far? We'll get a little information about rounding next. The big takeaway, I think, from the statements here is we want to try to only round one time per calculation, per problem. When doing a calculation, don't round along the way. Wait until the final answer. Every time we round, we get a little bit less precise, a little farther off from the actual answer. That's not going to be a problem with the mean because adding won't mean we need to round. It's only when we divide, which is already the last step. So we'll just round at the end. Means, as a rule, are rounded to one more place than you start with. The thing for us, though, is on my stat lab, they'll always tell us how to round. We'll always have rounding instructions. We noticed that the other day. We'll have a look at these other averages I mentioned, the median, mode, and mid-range, and then we'll do a practice problem and calculate all of them. So median is up next. See anything you want to double check so far, though? Well, the mean is one way to measure the center of a data set. Summarize it, in other words, by saying where its middle is. The median's another way to do it. It says the median is the halfway point in ordered data. So maybe imagine you have a list of numbers, you put them in order, and then you literally count in from each end to find the middle. That would be your midpoint, or I'm sorry, your median. So putting it in order is important. The little example I cooked up here had 5 values, so there was a middle number. There may be an even number of values that doesn't have a true middle. So what we do then is add the 2 in the middle and divide by 2. When there's a tie for the middle, we're going to add these 2 and divide by 2. In other words, we'll figure out what's halfway between them. So that's a very visual kind of middle, just picking the middle number after the numbers are in order. The mode is kind of different, a different sort of average. The mode is the data value that occurs most often. Some people say the word mode and the word most sound alike, so it kind of helps them link those two together. The mode is the one that occurs the most. If you have a tie, if there are two that occur more than any others, we could say it's bimodal, which might sound kind of familiar. Do you remember that as one of our shapes the other day? We said if there are two bars taller than all the rest, we would call that shape bimodal. Bi meaning there's two values that we have the most of. It's possible, by the way, to have no mode. If there's no one number that occurs more than the others, no mode is possible. A little later today, we'll be looking at grouped data again, data that's already been grouped into classes. And then we won't say just mode, but we'll talk about the modal class, which is the class that has the most in it. Or in other words, the class with the highest frequency. So mean, median, and mode so far. Fourth one, last one on the page here is mid-range. Says to find the mid-range, we're going to sum or add the lowest and highest values in the data set and divide by 2. So the lowest, as in the minimum value, plus the highest, as in the maximum value, and split the difference, divide by 2. That's a real physical way of measuring the middle. We're actually looking at the highest and the lowest and then just splitting the difference and finding what's the halfway point. Lots of different ways to approach basically the same idea, talking about the middle of the data set. Got a data set on the back of the page so we can practice all of these, see exactly what they look like. Anybody want to double check anything on the front side before we do? No problem. If you're ready, then you might flip it on over, have a look, see what we're getting into. Get started on finding the mean if you want. We start with whole numbers, so let's round to tenths. So for the mean, hopefully you started by adding everything together. Looks like that comes to 1205. And then what do we divide by? 7. And if we round that to tenths, looking like 172.1. Nice. Let's label that answer with a symbol. We said if we're calculating the mean of a sample, we use one symbol, or population, we use another. Is this a sample or a population? Sample. So which symbol should we use?
X bar.
X bar. You got it. Anybody use a little help with the mean? What's the first and most important step for finding the median? Put them in order. Yeah, these they're not too many, so you might do it by hand. Or remember, you've got your calculator list you can use if you want. So once they're in order and we count into the middle, is there a middle number? 172. All right, so the median is 172. Since the median is the middle number, that ensures that 50% or half of our data will be before the median, and then the other 50% will be after or above. What are we looking for in the mode? Do you know which one is the mode? 169? Yeah, how come? That's the one there was the most of. That's right. We had 2 of those, didn't we? And everything else disappeared once. So for the mid-range, what numbers do we need? 169 and 176. Yeah, we want the lowest one and the highest one after they're in order, right? Not just the first one and the last one, but the lowest one and the highest one. These 2 numbers get added and then we divide by 2. Yeah. You can do that in 2 steps, or you can use parentheses and make it all 1 step. Do we know what the mid-range is? Sounds great. Those 4, the mean is the only one that will need rounding. The mean is also the only one that has a special symbol, the X bar. Do we have a unit for our numbers, the LSAT scores? I don't see anything. If we had a unit, we could attach that to our answers. Like if it was in, you know, thousands or dollars or feet or something like that. What do we have about with so far in our 4 measures of central tendency? Also known as averages. Well, in this 2.3 homework is when we'll start having some questions about the shapes. And that's because these 4 measures are closely related to the shapes. Do you recognize this one here that we called symmetric the other day? When a distribution is symmetric, the mean, median, mode, and mid-range are all equal. As far as the picture goes, can you imagine how we could maybe pick out the mode on that graph? How can we pick which one there's the most of? Where are we gonna see the one that there's the most of? The tallest bar? So the mode is right here in the middle. Remember, the height of the bars dictated by the frequency, so whichever one has the most would be the highest frequency, and therefore the highest bar. As far as visualizing the mean, let's not think of this like a seesaw or a scale or a balance. And think about, where would the little balancing point underneath need to go to make it balanced? In the middle. That's a way to visualize the mean. Wherever this balancing point would go, keep it from toppling over to the right or to the left. That's what the mean looks like visually. So it also is in the middle, same as the mode. And then the median, remember we said, has 50% of the data to one side and 50% to the other. So think about all this shading in the bars and where you could split that shading in half. That's going to represent your median. The shading also would split in half right in the middle. So we can kind of visually see what they're saying, that the mean, median, and mode would all be right there in the center. That sounds right. It might not sound, it might sound strange to say that these could ever not be in the center. But this one was really balanced, right? Symmetric, it's very balanced. Right skew on the other hand is not so balanced. See if you could identify some of the same things. Can you find the mode? Maybe think about where the median or mean would be. I'm gonna give you a minute to study on that. Since this one's a little bit lopsided, right? Skew. The three measures are not all the same. They're not all smack dab in the middle. Where is the mode? Tallest bar to the left this time. That's right. And what if you considered all of this shading and wanted to split it down the middle? Do you think? Let's see, if I went in the center, right there, does that look like an even split? Is there the same amount of shading on the left and right? No. What do I need to do? Shift it a little bit to the left. So a little bit more like this. Somewhere in that range would be our median. You can't pinpoint it exactly from sight, but just kind of getting used to what it means. And then let's think about this like a seesaw or a scale that we want to balance. If I put that balancing point right in the middle, do you think that would do the trick? Or would you shift it a little one way or the other? Maybe left a little? Yeah, and it's gonna end up being above the median, which is also above the mode. So these don't line up exactly because it was kind of lopsided. But we can kind of start to see how it all comes together, what these measures have to do with our shapes. On the next page, there's a right skew, which is just exactly opposite. And a case study, which we're gonna skip for now, because I want to make sure we get certain things in, and then we can come back and do it when time permits. So I'm actually gonna ask you to jump on over to page 4. Unless there's anything here you want to double check first. Well, the data set we worked with a minute ago was just raw data. As in, we knew the individual numbers, nothing had been done to them yet as far as organizing or displaying. What we're getting into on this next page is information that has already been organized. So when we have a grouped frequency distribution, we have to approach things just a little bit differently. Let me ask you to check out the example in the middle of the page there, see what the information is about. It says that 30 cars were tested for their fuel efficiency, as in miles per gallon. They're asking us to find the mean and modal class. It's a little bit different than what we were doing before, because we don't know the 30 individual numbers this time. They've already been grouped into classes. What is this 3 right here telling us? 3 of the cars had what? 8 to 12 miles per gallon. Can you tell me exactly what those 3 numbers were? We don't know, do we? So we've lost a little bit of the detail. We can still approximate the mean. We just can't do it exactly the same way. Do you have an idea what number might represent that class well? Like, in other words, I don't know the 3 numbers exactly, but I know they're all really close to 10. Yeah. What about the next class? What do you think would be a good number to represent that class? 15. 15? Yeah. Do you remember from the other day what these numbers are called? These are the class midpoints. You got it. So we're seeing a use here for our class midpoints. Give me a minute to try filling in the rest. If you're having any trouble figuring where we're getting these mystery numbers from, might remember for class midpoints, you add the limits and divide by 2. Like 8 plus 12 makes 20, divided by 2 makes 10. What are the other midpoints? We've got 10, 15, 20, 25, 30. Nice. You probably didn't even have to calculate all of them, right? Once you see the pattern, you might just fill them on in. So a little review there with midpoints. Anybody need a hand filling in that column? Okay, so think with me here for a second. I don't know exactly what these 3 numbers are, but I do know they're all really close to 10. So let's just represent each one of them with a 10. We have 3 numbers really close to 10. We have 5 numbers that are all really close to 15. That's basically what we're going to do to calculate our mean. Use 10 to represent the numbers in that class. Use 15 to represent the numbers in that class. It's a kind of a big job, a little tedious though, to really do all of this adding separately. Can you think of maybe a shortcut, like another way to figure out what 3 10s are going to add up to? They're going to make 30, yeah. And we can multiply to get that result. 3 10s would add up to 30. 5 15s would add up to 75. So let's do some multiplying as a shortcut to save us from all that repeated addition. Like 3 times 10, 5 times 15. And the same all the way down. 15 times 20, 5 times 25. Getting a 300, a 125, and the last one would be 60. Great. So we're kind of adding up this long list of 30 numbers bit by bit. I've already added up the 10s and the 15s and the 20s. I really need a grand total now, so let's add all those results together. And that would be kind of as if we had added all 30 numbers individually. So as far as the mean goes, now that we have the grand total, by hook or by crook, we approximate it. What should we divide by?
5 or no?
How many cars were there? 30, yeah. So 590 divided by 30 will give us an approximation of the mean. Tenths would be good here again. Like 19.7. We had a unit this time also, didn't we? 19.7 what? mpg, miles per gallon. Great. We've essentially done the same thing. We just went about it a little bit differently. Partly because we didn't know the exact numbers. And partly because we shortcutted the adding with a little bit of multiplying. But that is how we find the mean for a grouped frequency distribution. That whole process we just went through is summarized in these formulas. So if you notice what's going on here, you can see the X represents the midpoint. That's the first thing we did. Step number 1. And once we had the midpoints, we did this multiplying. That's the times F here, step number 2. And once we had that list of numbers, what was next? It was time to add them all up. Step number 3. And then once we had that total, 590, we divided by n. Step number 4. You just looking at that formula, even if you recognize all the symbols, it may not help you know what to do first and second and third, but it does follow the old order of operations from algebra called PIMDAS. Do you remember? Please excuse my dear Aunt Sally. PIMDAS. In other words, that's how I know to do the multiplying before the adding. It's as if this was in parentheses. Multiplying happens before adding. A couple last things that we want to look at and mention with this particular page, but any questions on your mind before we do? Not sure I stopped for questions recently. Yeah.
I don't know what N1.
The number of values, because they told us 30 cars.
Oh, okay.
We did. Sometimes they don't give us that number though. Yeah, in that case, you add up the frequencies. Yeah, and that's why there's a second version of the formula. You might notice up here, they're pretty much identical, except for this. If we don't know n outright, we can find it by adding up the frequencies. N is going to equal the total frequency. So if they hadn't told us there were 30, we could add up this frequency column and find 30 for ourselves. Just two different possibilities. An easy mistake to make here, though, is to divide by the wrong number. 5 is a popular choice. And I think it's because of the 5 classes, maybe, right? So notice we don't really care how many classes there are. We really want to know the total frequency, like 30 cars. Lastly, about this one, it said find the mean and modal class. So we've worked really hard and figured out the mean, but we do still want to add on the modal class. Thankfully, it's a lot quicker and easier. We've already got the hard one out of the way. Let me give you a second to remember what we said about mode and maybe even what we said about modal class. That the mode was the data value that occurred the most, or in other words, with the highest frequency. Modal class is the class that has the most or highest frequency. That's right. So out of our frequencies, 15 is the highest, isn't it? And that goes with 18 to 22. So that's our modal class. The one with the most in it, like in this case, 18 to 22. We could put our unit with this answer also, 18 to 22 miles per gallon. I think we've hit all the little extra details. What do you see you'd like to ask about or maybe add to what we've said? We'll want to practice that again, and I'm thinking maybe after break. Are you ready? Let's do this. We'll get started again in 10 minutes. Let me know if you have any questions on your way out, or if there's anything I can help you with.
Yes.
I can check it. I'll check it. Thank you. I appreciate it.
Oh, yeah.
What would be your disturbance in my training district?
So let's start to come back together. I ripped something up of a shoebox I had at home, said, it was a little bit funny, said average contents 2, which kind of gives the idea you might get more than 2 shoes or less than 2 shoes or exactly 2 shoes. But what if every box had 2 in it? Would the average be 2? Yeah, and I got kind of lucky. I ended up with 2 shoes, so that was good. One left and one right. Also wanted to mention this mean for grouped frequency distribution that we've been working on is one of the things there's an extra video about on Blackboard under course content. So here we go right here, 2.3. Just a little 4-minute video showing an example like we just did. And later on today, we'll be talking about something called a weighted mean. There's also an example of a weighted mean. So, like we have mentioned in the past, some extra videos in case you need them. Well, is there anything on that page you want to double check before you give it a try again? We had our plan up at the top. We've got our sample here to go by. So flip the page back whenever you need to. But basically, it's your turn to give it a try with the data here on the next page. I'll be wandering around to help and answer questions, so flag me down when you need me. We end up needing to round, tenths is still a good way to go. Anybody like a little help?
We still running up to the 10th, correct?
Tenth sounds good, yeah. See a lot of people finding midpoints. Great start. Some of the beginning steps are filled in on the screen. You want to double check anything? Need a little help or see anything you want to ask about? Just let me know. Can we put a unit on our answers this time? Dollars? Anything else? Million? Yeah, $1 million. Something good? Does 1929 sound good for the grand total? And then what should we divide that by? 45? They mentioned 45, or we can add up the frequencies. So 1929 divided by 45. And round it to tenths, looking like $42.9 million for the mean. Sound okay? Anybody need a little help up to that point? You sure work hard for the mean compared to the modal class, don't you? What will the modal class turn out to be? 32 to 42? That's the class with the most in it. 15 is the highest frequency. 32 to 42 is the modal class. Well, find before too long that formula actually will do other things for us as well. Not only will it find the mean of a group frequency distribution, but it'll also find something called a weighted mean. So we'll be kind of building on that in a minute. What could we help out with before we move on, though? Do you want to check on up here? All right. Well, we mentioned a weighted mean, and that is a mean where an extra factor is taken into consideration. So if there's some extra variable or factor you want to bring into your calculation, weighted mean is the way to go. This formula here probably looks kind of familiar because it's basically the same as we just were using the x times the f for frequency, but in this case, x times w. Sum of the f for total frequency versus total w here. So that w there stands for the weight, which is the extra factor we want to take into account. And what we're seeing is we can basically treat that just like we did frequency. We don't need a whole new approach. We can use the same idea for any extra factor that we want to take into account. Kind of like the problem at the bottom where they're asking us to find the weighted mean price for the 3 types of helicopters shown. Weighted mean price. Beep, beep, beep. So let it sink in for a sec, give you a minute to read over the next example we're going to look at. Don't know much about helicopters. Apparently they're not cheap, right? These prices may not even be current, I don't know. So one out there called a sun scraper that sells for $427,000, or did at one time. High coaster, a high flyer, different prices. So we don't want to just add those 3 numbers and divide by 3. Because they're asking us to find a weighted mean price, meaning we like to take into account, more of this one sold than that one. And even more of this one sold than the other two. So we wanna show that, this one is weighted a little heavier or counts a little more, because so many of them sold. The trick really to applying this formula is deciding which column of numbers is the X and which column is the W. Easiest way, I think, is to look at the question. Like they want the weighted mean price. That means price is going to be the X. Whatever they want the mean of, that's the X. And then the other factor is the W. So on this column, we're going to treat price as our X, which means the number sold is the weight, W. What we do is no different than what we did before. We're going to multiply each pair of numbers and then add up to get the grand total. Where the difference shows up a little bit is what we divide by. We need to just make sure to add up the correct column there. So let me give you a minute to jump in, start doing some multiplying. We're going to get some great big results here. Like 9 times 427,000 is 3,843,000. Sound like a good start? Let me know how many million when you get to that grand total. Yeah.
800, 8,700, 300, 700, 33,000, and yeah.
Yeah, great. So that's what we're going to divide into. Divide by 27? Yeah, and where does the 27 come from? That's the total. We want to divide by the total of W, which in this case is the number sold. So we'll add up that column. 9 and 6 and 12. And 29. 9 and 6. Oops, that's not it. 9 and 6 and 12. I'm gonna stick with tenths. Like 545,666.7. And the unit this time is dollars. So remember, again, we're not just finding the average for the 3 types of helicopters, but the average for the 27 helicopters sold. And what we're finding is the weight there can be frequency or it can be other things. So in this one, number sold, it really is a lot like frequency. It doesn't end up being very different at all. We're just asking the question a little differently. Find the weighted mean price. A real common use of a weighted mean is GPA, grade point average. And we'll work a problem involving GPA when we flip the page. Is there anything we want to check on before we do? In my notes here, I said that X was the data value. Something to write down if you think it'd be any help to you. W is the weight. And again, remember, whatever they're asking about, that's going to be the X. Like weighted mean price helps us know price is the X. And the other information is the weight. Well, this is a copy from a homework problem. So we'll definitely want to make sure we've got this GPA thing figured out, help us be ready for homework. There's a lot of information packed in to what they tell you. So let me give you a minute to read and start kind of sorting out what all we know. I'm noticing they talk some about the grades the student has received, and they talk some about the points that the different grades are worth, and the number of credits the different classes are worth. So as I get organized, I'm thinking there's going to be grades and points and credits. Let's start with grades. Can you tell me what grades this student earned? Student receives the grades shown below. Okay, so where's below? The student received an A in one class, a B in two classes, a C and a D. So I'm going to put A down one time, B down two times, C once and D once. Each letter grade is worth a certain number of points. You see where they're telling us about that up at the beginning? It says with an A worth 4 points, a B worth 3 points, and so forth. So the A they earned will get them 4 points. The B was worth how many? 3. The other B is also worth 3. C is worth 2 and 1 for the D. Well, there's one column of numbers we have to work with. Could be the X, could be the W. We'll have to figure that out in a second. Let's go back then and see what the credits were for each of those classes. So now I'm kind of looking at this part again. This doesn't have to be in any particular order. I'm just trying to kind of get my thoughts organized, get all my information together. How many credits was the class worth that this student earned an A in? Looks like that was a 4-credit class. It says they received an A in one 4-credit class. And how many credits were the classes that they got a B in? 3. Okay. A B in 2 3-credit classes. Good. And what about the one that got a C in? 3. A C in a 3-credit class. And the D? 2. Great. A lot of different types of numbers in there, aren't there? Well, there's our second column of numbers. So now we have one for the X and one for the W. We just need to figure out which one is which. Take a second to find the question and see if that'll help you decide which one should be X. What is the student's grade point average? My choices for X are points or credits. They ask about points there, don't they? So that's going to be our X. That means credits is the W. And once we have that figured out, we're ready to roll. We're ready to multiply and add. Do some more adding and some dividing. Probably won't feel any different from this point now that we know what our information is. Give you a minute to try filling in the rest of the numbers and finding that GPA. After I multiply and add up, my grand total's coming to 42. Anybody else getting 42? So we're gonna divide into 42. What should we divide by? 15, where's that come from? Adding up the credits, yeah. 4, 3, 3, 3, 2. And I know I want to divide by the total of the W, so I'm just making sure to add up the W column there. Are we gonna need a rounding rule? No, we don't, do we? It doesn't go on and on. Comes out 2.8. No rounding necessary. It's a reasonable answer, right? Because the points the student earned were somewhere in between 1 and 4. They had a little bit of everything. So right in the middle of 1 and 4 would be 2 point something. 2.8 looks like it's pulled a little higher because of those 2 3s. Right? Otherwise, it would be real balanced. There was a 1, a 2, a 3, and a 4. Then that extra 3 pulled it up a little bit. If I was sitting down to do my 2.3 homework, I'd have that right in front of me. And I can mimic it until I get the hang of it, unless it's already something you're good at. But I use that as a guide to get you through those homework problems. Kind of strange and confusing the first time you see it, but then they all start to feel the same. So hopefully it'll be boring and old news by the time you get done with your homework. What would you like to ask about it for now? So what page did we skip over? It was back on 3?
Yeah.
Yeah. Let's go back to 3. And give it a few minutes with a neighbor or a couple of neighbors grouped together, as much or little as you like, to check out the case study. I'm gonna stick with tenths for any rounding I need to do. Anybody like a little help getting started? Clear. Unclear down. You need them lowest to highest. You need them in order first, yeah. You're ready, and you and your group agree on some answers. We can use the hand filling in the number 1 answers and number 2 on the board. Come on down when you're ready. I can help with so far. Yes, we do.
That's, yeah, 11,000. Maybe you're gonna see the lowest number in my place, and then the other, like, 10,000, 11. Plus 107,000. $58,000. That's just. This would be the lowest number even though.
I can share.
I think I had to do it. Got some answers on the board for you to compare with when you're ready. Oh, are we liking the looks of the meat on the board? 22,921.7. That comes from adding everything together and dividing by 12. 22,921.7. And do we like the looks of the median on the board? 16,500. Once the numbers are in order, we're gonna count in from each side. Looks like we have a tie this time. So we'll want to add 16,400 and 16,600. Divide by 2. Looking good. Anything we can help out with so far? Are we happy with 11,000 for the mode? There were 2 11,000s, which was more than anything else. Yep. And are we happy with the mid-range? 58,500. Yeah. Where does it come from? You took the lowest, which was 10,000 plus what?
Watkins.
The largest, 107,000 divided by 2. No more question mark. Excellent. Do you remember the difference in parameters and statistics?
Yes.
It's sample versus population, isn't it? So these were, was this a sample or a population? Sample, they told us right there, didn't they? Making them statistics. Nice. Nice. So remember, all 4 of these are averages. They really are. You could say the average is any one of these 4, and you'd be correct. They paint a different picture though, don't they? The answers vary a good bit. So if a school board thinks that the people here already make enough money, they don't want to give them a raise or increase their salaries, which average would make it look like the salaries are already plenty high?
Maybe the mid-range.
The mid-range, yeah, the 58,000. The mid-range doesn't always come out the highest. It depends on the data. In fact, that's why there are 4. If 1 was always the best, we wouldn't have to talk about it so much, would we? The teachers, on the other hand, say, no, we don't make enough money. We do need a raise. We only make on average, which one? 11,000. The mode in this case would support their argument the best. And they would also be telling the truth. Why do you think the numbers vary so much? You notice that one number that was so different from all the others? Yeah, which one was it? The 107? Right, that number that's so different from all the others is called an outlier. Not liar like you don't tell the truth, but liar like it lies over there. Lies out away from the rest of the pack. The mid-range is greatly affected by an outlier because it's only based on 2 numbers. If one is super high or one is super low, it's going to impact that mid-range. That's what pulled it up so high. The mean, on the other hand, was a little bit impacted by it, but not as much because all 12 numbers figured into it. So it pulled it up a little, but not as much. Out of our 4 answers, which one do you think gives the best picture of the overall data set? I think I hear some folks saying the mean, 22.9.
Yeah.
So if we think about the mean in relation to the others, it's kind of like here, yeah? It's actually higher than almost all of the numbers. Maybe we could do better.
16.5.
16.5. So we definitely have some below and some above. Seems like it's a good idea of the middle in this case. I think probably for this data set, the median looks best. If you told someone the average is 16.5, they probably wouldn't be shocked when you showed them the rest of the numbers. They'd say, oh yeah, I expected some a little higher, some a little lower. What's going on with that 107? That's probably what they would say, right? Median looks like a good bet in this case. Some of them represent the whole set better than others because the outlier has such an impact. So we'll see that word again, outlier. O-U-T-L-I-E-R. As we wrap up the case